We're just jumping around. What is the holographic principle? What does that mean? What is there some kind of weird projection going on? What the heck
Well, I was
is
just
this all
before I
about?
came here writing an introduction to a paper, and the first sentence was the as yet imprecisely defined holographic principle. Blah, 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 blah.
Nice.
So nobody knows exactly what it is, but roughly speaking, it says just what we were alluding to, that really all the information that is in some volume of space-time can be stored on the boundary of that region.
So this is not just about black holes, it's about any area of space time.
Any area of space. However, we've made sense of the holographic principle for black holes. We've made sense of the holographic principle for something which could be called anti-de Sitter space, which could be thought of as a giant, as a black hole turned into a whole universe. And we don't really understand how to talk about the holographic principle for either flat space, which we appear to live in, or asymptotically de Sitter space, which the astronomers tell us we actually live in as the universe continues to expand. So it's one of the huge problems in physics is to apply or even formulate the holographic principle for more realistic. Well, black holes are realistic; we see them, but yeah, in more general context, to give a more
So
general statement of the holographic principle.
what's the difference between flat space and asymptotic de Sitter space? So flat space is just an approximation of like the world we live in. So like de Sitter space, asymptotic. I wonder what that even means. Meaning like asymptotic over what?
Okay, so for thousands of years, until the last half of the 20th, well, sorry, until the 20th century, we thought space-time was flat.
Can you elaborate on flat? Well, what do we mean by flat?
Well, like the surface of this table
Mm.
is flat. Let me just give an intuitive explanation. Surface of the table is flat, but the surface of a basketball is curved. So the universe itself could be flat, like the surface of a table, or it could be curved like a basketball, which actually has a positive curvature. And then there's another kind of curvature called the negative curvature. And curvature can be even weirder because that kind of curvature I've just described is the curvature of space. But Einstein taught us that we really live in a space-time continuum, so we can have curvature in a way that mixes up space and time. And that's kind of hard to visualize.
Because you have to step what a couple of dimensions up, so it's hard to.
You have to step a couple, but even if you have flat space and it's expanding in time, we could imagine we're sitting here, this room, good approximation, it's flat, but imagine we suddenly start getting further and further apart.
Mm.
Then space is flat, but it's expanding, which means that space-time is curved.
Ultimately, it's about space time. Okay, so well, what's de Sitter and anti de Sitter space?
The three simplest spacetimes are flat spacetime, which we call Minkowski spacetime, and negatively curved spacetime, anti-de Sitter space, and positively curved spacetime, de Sitter space. And so astronomers think that on large scales, even though for thousands of years we hadn't noticed it, beginning with Hubble, we started to notice that space-time was curved. Space is expanding in time means that space-time is curved.
Mm-hmm.
And the nature of this curvature is affected by the matter in it, because matter itself causes the curvature of space-time. But as it expands, the matter gets more and more diluted. And one might ask, when it's all diluted away, is space-time still curved? And astronomers believe they've done precise enough measurements to determine this. And they believe that the answer is yes. The universe is now expanding. Eventually, all the matter in it will be expanded away, but it will continue to expand because, well, they would call it the dark energy. Einstein would call it a cosmological constant. In any case, in the far future, matter will be expanded away and we'll be left with empty de Sitter space.